They will be uploaded on our YouTube channel after the whole masterclass series. And in case you're not aware, this is actually our second last masterclass series. So we just have one more to go. Then after that, you can view all of our masterclass series for this season on our YouTube channel. Okay. So the topic for today is analyzing Forex foreign exchange data for price prediction, and we will be attempting to apply data analysis and machine learning to analyze the daily recorded data of GBPUSD to gain insights into the data and make predictions. Of course, I will not be the main speaker for today, so I will introduce our speaker. But before I do that, let's just set a few ground rules so that we actually have a very fulfilling session today for better audio purposes as well as not interrupting the whole flow. So we actually have put everyone on mute throughout the session. But if you have any questions along the way, just feel free to put them in the chat and I will actually help share this question with the speaker themselves, and then they'll actually address the questions accordingly. And of course, in between, if you wish to give support to our speakers, just feel free to react in any way. So let us test out if the reaction buttons are working. So can everyone just give me a thumbs up? Do you know where to find the reaction button? All good? All right, I see thumbs up coming in. Okay, so at any point of time, do give our speakers a support by giving them a thumbs up or the clapping emoticon as well. All right. Okay, so now let me finally introduce our first speaker for the day. So our first speaker is Mr. Bhishma Sakaran, who has actually more than 12 years of extensive experience in technology services across global firms, carrying a wide range of experience in various machine learning modeling, core programming and software development, as well as the digital transformation initiatives. Of course, he has a lot of in-depth knowledge and experience in various industries, from technical solution providers to financial services. He also brings a world of corporate knowledge, which reinforces his skills to impact and connect during his training engagements with the audience, which we'll be able to see today. So yeah, let us see how today's session will go. And without further ado, let us welcome Bhishma. Bhishma, over to you.
Thank you very much, Stephanie. Good evening, everyone, and welcome to SIM's Masterclass in Applied Financial Machine Learning for Forex Prediction. I'm your guest lecturer for the evening, Bhishma Sekaran from Zaltius. At Zaltius, I've been a machine learning engineer for the entirety of my time here, but previously I was involved in a private investment partnership in the United States, where we spent a good amount of time considering this trade. So tonight we're going to discuss a currency major, the pound sterling against the US dollar, also known as Betty. This class will take around 60 minutes, and I'm told a good amount of time has been reserved at the end for your questions, so there's no need, happily, for me to rush. We will be covering the topics of why Betty, background information about general Forex, a brief look at the United Kingdom, a brief look at the United States, a small look at global macroeconomic conditions as they are at the moment, and then for the practical portion of this masterclass, we'll transition into examining two modeling techniques in Python, one traditional and one slightly more modern, used to do forecasting. So a little bit of admin before we begin. I'm presenting off Canva to start with, which is where our designer very helpfully fixes up the slides after I've done mutilating them with my engineering squiggles. I will have a PDF conversion of these slides for you. And once we're done with these slides, as I mentioned, we'll move on to the Jupyter Notebook for the practical session. Both the original notebook and the PDF conversion of it, in conjunction with the 27-year historical data set of the pound against the dollar, will be made available to all participants after the session time. So with that out of the way, let's begin. Why Betty? Now, here in the middle, of course, we do not have Betty, rather we have Eliza. Audrey Hepburn played everyone's favorite Cockney heroine opposite the legendary Rex Harrison in My Fair Lady, a film adaptation of a musical adaptation of George Bernard Shaw's Pygmalion. The Cockneys have a unique rhyming slang in which they match word pairs to a rhyming word, and then they drop the rhyming portion using only the non-rhyming section as a reference. So Betty does exist up here on the top left. Here you see her in the iconic, I think, 1951 pose. And her full name, of course, is Betty Grable. And Betty Grable rhymes with what you see down here, the submarine telegraph cable between London and New York. And that's what Betty is. Betty is the cable referencing the sterling $2 currency major. Some other toy examples down here for us to have fun with before we keep going. Apples are a staircase. Apples and pears, the stairs. China is your friend. China plate, your mate. And germane to our topic tonight, bees mean money. Bees and honey, money. So let's move on. Currency trades, perhaps more than any other class of market operation, rely heavily on background global macroeconomic information. We need to know a great deal about both countries involved in the currencies that we are trading, not only their relationship with each other, but also their interconnectedness to broader world events with regards to political developments or trade or potentially military developments. So we have to consider the dollar on the one hand and the pound on the other. And on both sides, we have to consider both the political and financial leadership of each country, and then compare them to each other and see if we can draw a positive or more often an invidious distinction. So let's start out with the United Kingdom. In the present day, Prime Minister Liz Truss leads the country, not having been elected, but having succeeded in a Conservative Party leadership challenge after Prime Minister Boris Johnson was forced to step down. Here in the middle, you see Chancellor of the Exchequer Kwasi Kwarteng insisting that he wasn't going anywhere. The same week, he was sacked and replaced by Jeremy Hunt on the right. I knew this would happen as I was preparing the class. I was watching carefully to make sure that Jeremy Hunt himself would not be displaced before we started class this evening. Happily, he's still there, and for the moment, Prime Minister Truss is still there. But I would say it's fair to argue that general market sentiment regarding the stability of political leadership of the UK is middling to weak at best. Some background about the UK itself. The current population estimates for 2022 place it at around 67.3 million, with England and the adjoining kingdoms. The UK is considerably less diverse than the United States. It is 87% white and 13% non-white. And of course, being a smaller country, its economy is much smaller. The nominal GDP for this year has been forecast at $3.376 trillion. So there's the UK as is. In addition to the trade against the dollar, in addition to Betty, the pound has faced severe selling pressure this year, particularly after Prime Minister Truss's appointment. Now let's discuss the United States. Here on the left, we have leader of the United States, Joe Biden, aka John Brandon, as he's depicted in, I think, a very trending piece of online propaganda which he's co-opted. And then here in the middle is Chairman of the Federal Reserve, Jerome Powell. And floating off to the corner of Chairman Powell is Chairman Volcker from the 1980s. And it's germane to mention Chairman Volcker because just like Chairman Volcker, Chairman Powell is not an adherent of the zero interest rate policy that has dominated from the time of, I would say, Alan Greenspan through Ben Bernanke through Janet Yellen until now. I'm sure you've all seen in the news that his Fed is very aggressively seeking to hike interest rates and continues to do so to fight the core cause of inflation. A move which many disagree with, but many also agree with. To be non-partisan here, I will not state my own opinion. But this has had a tremendous impact on the dollar, of course, because as the US raises rates, it makes the dollar quite attractive safe haven for international investment. And so United States treasuries, risk-free investments, have done considerably well, as has the dollar itself. US equities, not so much, but that's not the topic of discussion this evening. So a friend on Reddit created a quite delightful animation about Betty's recent history, looking at the pound versus the dollar. Let's have a look at this video. Again, some of which you might be familiar with. I see a Let's Go Brandon chat. Sadly, that does stop at September. It gets quite exciting, and I'm sure we'll continue to do as we keep going. Now, in addition to the two main participants, of course, we also have to consider other global macroeconomic factors, particularly the war in the Ukraine, which shows honestly no signs of abating on any part. The Ukrainians have put up a spirited defense of their territory. The Russians, for their part, show no sign of ceasing their special military operation. This will lead to probably severe consequences for Europe as a whole this winter. You can see in the middle a map of the various pipelines supplying Russian natural gas to many of the European states, particularly Germany. And given that one of the Nord Stream pipelines has been sanctioned, and the other, this one, Nord Stream 1 here, which is transoceanic, it's as you've seen in recent news, suffered damage attributed to unknown causes at the moment. So that's a situation in Europe. Situation in Asia is not ideal either. As mentioned, the increased rates in the United States have led to a series of fund outflows from this region, in addition to other factors like the slowdown in the Chinese economy, the long-term stagnation of the Japanese economy. And so all of this plays a part in the general suppression of the equities market at the moment. As regards Betty, all of this is great for the dollar and not so good for the pound. Now, having discussed the macro and how we analyze this on a fundamental basis, let's talk about a more technical sort of time series analysis. The two models that we will discuss today are ARIMA, the autoregressive integrated moving average, and LSTM nodes. That's an abbreviation for long short-term memory. I've reserved a bit of time here for us to go into the theory because this can get abstruse, although I will endeavor to make sure that we all manage well with it. So let me enable my scribbles here. So here, if everyone can see my highlighting, ARIMA, as I mentioned, stands for Autoregressive Integrated Moving Average. This is a specialized form of ARMA, A-R-M-A, without the I. The autoregressive moving average, again, no I, no integration. So this is a foundational technique in time series analysis. Data points which have already transpired or occurred, we consider them to be lagged points, so-called, and we use an accretion or a grouping of them to make new predictions. So the formula here, although it can look awful, really, when simplified, it just says that our desired prediction here, y sub t, so the value of y at any particular time t, is equal to the sum of a constant term beta and the summation of the other lagged y's, this t minus 1 up to t minus p, multiplied by phi, which is another term, which we sum up up to the d term difference for the equation, which we need to provide. So we need to provide the time period of the lags and the level of differentiation that we want. And then the net effect of all of this is that the ARIMA model has the effect of remembering where it has been. And so therefore, in contrast to, say, a technique like drawing a simple gradient, we can generate cycles or repeated patterns, or as they call them in time series lingos, seasonality. So we can have regular occurrences of values increasing and decreasing according to predictable seasonal patterns. Again, not strictly locked into those exact values, but possibly heading along a general uptrend or a general downtrend, but following that season. So as mentioned, this is a classic technique and very, very well understood. It was developed in the 1970s by George Box and Willem Jenkins, and has seen continuous use since then, not just in the foreign exchange markets, but also generally for time series analysis for things like weather prediction, for things like population growth, for things like agricultural forecasts, and so on. Now here, we see the long short-term memory nodes in RNNs, or recurrent neural networks. So I realize I'm begging the question here. So before we move on to recurrent neural networks, let's talk about artificial neural networks. You've probably heard that term before in the press. It's become more and more popular. And artificial neural networks are actually conceptually older than ARIMA and ARMA. We, for almost as long as recorded human history, conceived of machines that are able to think or able to reason like we can. And so in the 1940s and 1950s, there was a development of a theoretical construct called the perceptron. And the notion was that these perceptrons, when arranged in a network pattern, would simulate the pattern of the real human neurons, which are interconnected in our brain. And so, although the mathematical basis behind the theory was sound, the technology of the 1940s and 1950s didn't permit that volume of calculation to be executed in anything like a reasonable amount of time. So it's only been very, very recently, within the last decade, that we've had computer hardware powerful enough that those designs from the 1940s and 1950s were able to come to fruition. And so in 2012, there was a long-standing computer vision contest called ImageNet, and a neural network by a team of researchers out of the University of Toronto, Professor Jeffrey Hinton and his student Alex Krzyzewski. They managed a 75% accuracy, and since then it's been an ongoing and sustained boom in deep learning. So there are several types of nodes that you can put into an artificial neural network. You're not limited to just perceptrons. And the LSTM node is a method for us to give this memory technique, which we achieve mathematically through the equation for ARIMA, symbolically this way. So I realize that this possibly looks even worse than the ARIMA equation, but I'd like to promise all of you that it's not really that bad. And let's take it in pieces, and then I think it will appear much more clearly for you. So what is really significant and important for us to keep track of is the dark line up here on the top. This running across the top is what we call the cell state, or the current internal mathematical value that each LSTM node contains. And what happens, as you can see from these arrows, these are the various output. This generally goes to another LSTM further down in the network. This might be output out to an output node in the neural network. So what's happening down here, where you see the sigma, sigma, tan H sigma, are sequential layers which make use of the sigmoid and hyperbolic tangent functions to alter the cell state. So here in the beginning, we have this sigmoid gate affecting the cell state, and this is the forget gate. So if we receive an input that, when fit to the sigmoid function, results in a low enough value, it is capable of erasing memories from our LSTM node. If not, then we move on to this retain gate, where the sigmoid output is passed to a hyperbolic tangent output, and then in conjunction, they are retained in the cell state up here. Then finally here, there is an output style layer. And in this output style layer, you'll notice this is where our output arrow finally emerges and heads up. So although the technique is different and it involves the organization of the network and the ensemble of the symbolic logic here, rather than the statistical method in ARIMA, we still get a memory-like effect that comes into play with LSTM. And so just like our ARIMA model, our LSTM nodes are able to retain information that they've come into prior contact with when they evaluate new input. And as to which is better at doing a better prediction, we'll see that in just a moment. So here are some of the packages that we'll use in the notebook. Jupyter is an integrated development environment for the Python, R, and Julia programming languages. You'll see that notebook in a minute. Matplotlib is a plotting, graphing, charting library. Python is the language we'll use for this one, but as mentioned, I could have used R, I could have used Julia had I wanted to. And this orange logo here is the TensorFlow logo for Google's implementation of a neural network framework. And that's the end of the slides. So let me full screen that, and let's move on to the notebook. So for those of you who've never seen it before, this is a Jupyter notebook. It runs on, although it is in the browser, you can see it's running on my own system from the localhost address up there. And really all this is a convenience method for me to run Python. I could, if I wanted to, run Python in the terminal just this way. I mean, that's the original history of the language. But, you know, there's a lot of inconvenience to doing things 1970 stuff. One, I cannot go back and edit this text as much as I would like to. I have to issue terminal commands to back scroll my history, change it, adjust it. It is very much a nuisance. In contrast, here I have all of the state-of-the-art features of 1985 when it comes to clicking into things, adjusting them, highlighting them, moving them up and down. And so for data scientists, Jupyter is a wonderful, wonderful tool for us to do our work, manipulate data, create models, and collaborate with others. So there's a lot of importing happening in this cell. A lot of this is related to these libraries that I mentioned previously. So there's Pandas is a data frame library will let us store our table of results. NumPy is a numerical and mathematical methods library. It will let us do mathematical manipulations on our data. Matplotlib, as mentioned, is for plotting, as is Seaborn. The math library in Python we're going to make use of for, I think, the square root function. And then warning it and itutils, so these are just sort of window dressing. Importantly here, statsmodel.api will let us have access to an optimized ARIMA model. Although, since we do know the formula from the notes, and therefore we could sort of jury rig something by hand to calculate this manually, it's not worth doing, and it would be much, much slower than using the ARIMA library, which has been optimized for us. sklearn is the scikit learning library, and it is a very, very powerful and robust collection of non-deep learning methods. When I reference deep learning, I mentioned I'm referring to things like artificial neural networks and LSTMs. And TensorFlow is our deep learning library. And these TensorFlow imports down here are the types of layers that we'll need when we're building our model. So the first thing that we need to do for doing this analysis is we need access to our data. So I picked a range of years which I hope you all will find robust enough, the period from 1995 to 2022. And there are a wide range of choices for you to acquire this data. It is available for free. So the way I have elected to do it is I have stitched together data from the Open Currency Exchange website. You can, if you like, get live data through an API. The most efficient and costless option there is, of course, through a Bloomberg terminal, which I think is a $20,000 a year subscription. But underneath that, there are many live currency information ticker services. So you can get subscriptions to those for a few tens or hundreds of dollars a month, and then work on this live if you're interested in live trading or very short-term trading. So here, for those of you who've never seen Python before, we are creating a variable called df, data frame, and we're using the pandas read CSV method to grab this data, which I've pre-prepared ahead of time, much like a TV chef. And this is what it looks like. So it's in reverse chronological order with 2022 on top. And we get the closing price, the open price, the highs, the lows, the volume, and the percent change from day to day. And I always tell my data science classes it's always a good idea to poke around a data set before we attempt to do anything with it, which is what this .info method does for us. As you will come to see, should you take up the SIM program, and I hope you do, a very large proportion of any data scientist's time is spent in tidying and cleaning up data. So here, conveniently, of our 7,105 entries, we actually mostly have complete sets of results, except for volume, which is fine because we're not interested in using volume for this analysis. There's one thing that we will need to change at the moment. Date, as you can see here, although it looks like a date, it isn't really. The object data type, which is what D type stands for. That should be bigger, sure. I hope that's all right, text order. The object data type is just a string of characters with text. So to actually make use of it for a time series analysis, we'll do a conversion. Pandas gives us access to this toDateTime method. And so then we'll convert this date column, which at the moment looks like this, into an actual date time object. So we do that, you see it changes from the object type to the 64-bit date time data type down to the nanosecond of accuracy. And so here we have all these dates again. So since we're interested really only in the closing price, once we re-index and we set the date as the index column instead of the default zero-based Python indexing, we'll chart it, we'll take a look. Just as a verification check, I also pulled up the same chart from 1997 to today on macrotrends.net. I'll click between the two a few times. Hopefully we can all agree that this is the same chart and the data looks okay. I got a thumbs up, that's good, that's heartening. Right. So just one more quick stroll through memory lane. So here we have a small financial crisis around 1998. Not as significant for Betty as it was for this region. Another market crash around 2001. And then a very global effect here at the end of 2008 with the global financial crisis. And then, we continue on. And then several dips in the pound, as you can see, because remember, Betty is pounds over dollars. So here, around the timing of Brexit, you'll notice sentiment towards the UK enduring as an independent economic entity, free of the European Union, seems to have turned pessimistic. And here, of course, we're on the current downtrend, which looks to be continuing for a while, but we'll see what actually happens when we do our analysis. So two ways to do this. First of all, we'll do ARIMA. So we'll take just the price column, right, which is all we're interested in. We've already re-indexed on date, so no need to do that again. And the .copy method will allow us to create this as a data frame called data. I'm doing this because later on we would like df, the original df, to be left untouched so we can use it when we do our RNN. So lots of things that we need to do. We create this ARIMA model, and as mentioned, you need to pass in P and T and Q, the order of differentiation that you want, the number of past cycles you'd like to look back for, and your variable to justify. And so we've created a function here for doing that. And then if we take this function and then begin an RMR forecast, having split our data, I'll talk about splitting the data in a moment, we get a pretty decent model here. I just ran it on the back section with a very, very low error rate. Error being the distance away our prediction is from the actual result. So very, very low error here, which is a great result. As promised, let's talk about why we need to split our data set. So although we have our 7,000 odd records, which seems like a reasonable enough amount to hand to a model to begin training it, it behooves us to restrict a portion of the data away from the model. So that is, say, we excluded the period from 2020 onwards. And the reason we have to do this is our model, if we train it on all of the data that is available, then we won't have an idea of how it will perform when it encounters new unforeseen conditions. So it's very, very important that we split our data, and generally people do something like a 70 to 30% split or an 85 to 15% split. Sometimes they go further and make subsections for validation portions of the data. And then we train on the training portion, and then we reserve the test portion to test against. So that's what we've done here. Of the 7,000 records, we took the record up until record 6039 and set that to be our training data. And then the rest of it we used as our test data. So ARMA, well tested, very, very well optimized library. It's extremely old, and it's performed incredibly well. It's given us a 004 error, and looks like it fits really nicely when we overlay it on the actual graph. So let's see how the LSTM model does. So here again, we'll use df.price, and we'll copy it into another data frame called LDF. And because neural networks are extremely sensitive to sizes of input, we are going to scale the inputs down between the range of 0 and 1. And what I mean by sensitive to input is if we take a look at the collection of neural networks down here, when you pass a result from one network onto another, you have to do a multiplication. And and if the result is too small, what happens is that you have some valid number, and then you're multiplying by a number that is so small it approximates 0, and then you get a result that also approximates 0. This is called the vanishing gradient problem. The other problem is if your number is too large, then you have two very large numbers that you're multiplying together. It's possible that you can overwhelm the physical memory of your system. That's called the exploding gradient problem. So holding or scaling our input values down to a range tightly constrained between 0 and 1 helps us neatly avoid this problem. And then we can always get our original values back later by upscaling back up again. Oops. So, I will cover this if we have extra time. If not, I'll provide all of you the link. So here again, we'll use a 0.85, 0.15 split between testing and training. So 6,000 odd records in the training side and 1,066 in the testing side. We'll make a function to create a data set from these results. And then this is just some NumPy trickery for us to rearrange these things into an input that NumPy will accept. So here are our training data and then here is our testing data. And then here, as I mentioned, is the reshaping because we need two-dimensional values. Remember, we're only technically using the price column, so that would just be one dimension, but we're adding a sort of dummy column, just that has no mathematical purpose. It's strictly for the convenience of the programming input. All right, so then here is where we actually design our neural network. So here I haven't created a very complex one. If you look at the LSTMs that exist here, generally you go from this yellow input layer into, here for convenience, I think they've listed it as 2. But people can do as many arbitrarily as you like. If you're at an organization like Meta or Apple or Google, there's almost no limit to the amount of hardware available to you. So I've restrained myself. I haven't done that many additional layers. I've added 3 LSTM layers from the input, and then I've set these input return sequences, and we're going to look back 100 days for each case, and then 1 dense layer in the output. Don't worry about all of this. This is just because I have a new graphics card. And then here we can see what our model looks like. So going from layer to layer, we end up with 50,000 trainable parameters, which seems like a lot, but especially if you go into computer vision and you start developing these kinds of things, the deep neural networks, you quickly run into model architectures that go up into the millions or tens of millions of trainable parameters. So this is reasonable. We can do this on our system, particularly since the system is equipped with a GPU. So we trained for 100 epochs, and epoch is 1 ingestion of the complete data set. And then the model actually trains very quickly. So it takes about a second and 9 milliseconds to train each step of the epoch, all 7,000 records. And then if we look at it, this graph of the training loss in blue against the validation loss in orange shows that we have really, really quite good results, because this is 0.0001 error. Very, very reasonable. And then here, if I overlay the training predictions against the test predictions, the most recent period, we see, again, this looks like a fairly decent method. So we do have to answer the question, what should you actually use? It depends really on several things. If you were doing live trading, you might want to tend towards the more modern approach, because you saw this executed very quickly due to the optimizations and the advances in modern programming techniques. Whereas I have to tell you, when I ran the ARMA this afternoon in preparation for this class, here on the training cell, this almost overheated my computer. So I elected to leave the results, again, like a TV chef, to leave the results pre-baked rather than risk attempting to run it and having it break on you. So this, because, and again, we can see why this is, right? Because we know from the formula that there are many steps that we need to run in this calculation. So computationally, it's not quite as effective. That said, results-wise, our results here for the ARMA model are excellent. So if we were, say, swing trading on this with a trade frequency of maybe a week or so, then that wouldn't matter if our calculation took, say, an hour or 2 hours, or even ran overnight. We could do that every evening, every morning, and then that would probably be a better way to go. Unless, and this is another thing, we haven't really done a lot here to develop an extremely sophisticated LSTM model. So we can add on many, many more additional memory nodes. And they are, when it comes to deep learning, there are an almost innumerable number of parameters, hyperparameters that we can adjust. When I say hyperparameter, I mean some factor that is extrinsic to our data. So this has nothing to do with, the historical rates of betting. This purely has to do with how we design the model, how we set how often it should train, and how much it should learn on each iteration of the epochs. So definitely there's a lot of room here. There's a lot of low-hanging fruit. This optimizer, for example, Adam, is always a fine one for a first pass attempt at doing a novel network. But there are optimizers such as stochastic gradient descent that allow much more finely grained accuracy, but it takes a long time to train them and fit them very precisely. So that would be an excellent project for a postgraduate who is taking a course like this. And oh yes, and then one other thing is we covered the global macro pretty extensively, but you'll notice it doesn't apply here. So what you would do in that case, should we jump to what you do in this case, if you had, say, very optimistic feelings about Prime Minister Truss, for example, and you feel that the pound is oversold at the moment, then what you could do is you could make an ensemble. You take the model here, and then you take the output that you get, and then you would scale it by some factor determined by what your macro analysis looked like. So if you felt that there were, say, there's good separation from Britain and the rest of the continent this winter, and the English fuel reserves are relatively higher than they are in Germany, which is the case, and you felt that Prime Minister Truss, despite her verbal gaffes, has at least the confidence of her party and will be able to weather this resignation of Chancellor Kwarteng, and then maybe you would be not so hesitant. And I still don't know if you'd go long the pound, but maybe you would go slightly less short, or you might hedge the trade more aggressively. Oh, and speaking of hedging the trade, we haven't discussed yet how we go about executing our strategy. So there are so many more options these days for taking a position. So we have, there is, as always, you can always take a position directly in either currency, levered or unlevered. Be careful about buying Forex on margin on your personal account, but stick to that professionally, unless you know what you're doing. Then, of course, there are many derivative options that are available, and not just directly with the currencies themselves. Say, for example, you felt that a particular sector of the United States economy might do very well, like agriculturals, for example, given the recent news that President Biden will be boosting a certain segment of the agricultural industry. Then you could select certain US tickers that you felt would outperform, and then you could short appropriately a set of British producers, either in the same industry vertical or in adjacent ones, or in an orthogonal one. So there's a lot of complexity that you can add when it comes to designing protective legs for your trades, or offsets, or hedges, which is not technically the scope of the class, but I felt I should mention that for those of you who are interested in going into this as a profession. All right, and with that, I think I meant to reserve 15 minutes for questions. So let me bring Stephanie back in.
Yes, thank you so much for sharing.
Very welcome. What a pleasure.
Yeah, it was actually very insightful. I mean, I have never really learned much about this. So it was my first time seeing all the data sets and everything, and it was really interesting. I hope the audience also resonates well with me. But yes, to the audience, if you have any questions, please feel free to type them in the chat here. You can react, you can raise your hand if you wish to unmute yourself and ask your question. And yeah, do also share with us your thoughts, what you think about like what's the next trend that we may be facing and everything. So yeah, just feel free to share, and we'll put it in rather than question and answer, we can also do like a little discussion. So just feel free to put it inside the chat, and we'll address it from there. Okay, any questions?
Oh, I have a private message. This is a good one. What is the difference between Python, R, and Julia? Yeah, that's an excellent question. So the three languages sort of exist in the state of equilibrium, where everyone feels that R is the statistical language. You saw how I needed to import ARIMA here as a package in Python to do the ARIMA. In R, because they, the language itself is developed to deal with tremendously large statistical tables, that level of functionality is very, very well integrated. Python is more the general purpose language. Python has been tremendously successful, particularly over, let's say, the last 10 or 15 years. It's not going anywhere, and it's frequently recommended to people as a first language or a scripting language that they should learn. I definitely do encourage everyone to learn a little bit of Python. Julia is a relative newcomer on the scene. So it exists sort of to be a better Python. There are a lot of idiosyncrasies in the language that people don't enjoy. And Julia has been written particularly for a scientific computing and machine learning focus. There is a wonderful package in Julia called toolkit.jl, equation toolkit.jl, and it is modeling toolkit.jl, and it is really, really good at symbolically solving things. So things like very classic calculus problems like the momentum or the energy of a spring, you can just enter that and you will get a solution in Julia very, very quickly, which is another feature of the language. It's built with something called multiple dispatch. So the computational paths in Julia are much more accelerated compared to Python or R. Very exciting language, and great question. Thank you. Okay.
We have 2 more questions, actually.
There we go. Yes, okay, let me do them in order. Benjamin, so I took these ones, I made it myself from an open currency exchange service, which lets you do PDFs, sorry, not PDFs, CSVs for up to 20th, and I just stitched the 2 CSVs together. Alternatively, you can pay for the service if you like through various vendors. I don't have a vested interest, so I won't recommend any one of them in particular. But if you need the data to do live trades, then you can certainly get it that way. Marcotte asks, what's a good way to start? Okay, so I would say pick, you probably won't go wrong picking Python because it is more popular at the moment. I am partial to Julia, but there is a tremendous wealth of material available for Python. We have lots of Python courses available. I'm sure we'll hear from Len shortly about the large amount of Python available in the course, should you take it. And I think that's a not bad list. And there's lots of free resources available, as well as for all of you who are Singaporeans, there are many, many skills future courses for Python, which you can take for a day or 2 to dip your toe in. Do I see Betty falling again? Okay, so I should limit myself, but okay. Well, you said specifically using the models. Yes, so the models do predict that. And I was going to say to the son of Lucy Van Pelt that the general macro picture for the pound is probably bleak at the moment. Weilam, is that a question?
Yep, I think you did address all the questions so far. Okay, there's one more coming just now.
Yeah, so how it works. Okay, I'll run through that again, Clay. So there's 2 ways. ARIMA looks backwards at a collection of what are called lagged inputs, so that means the prior data. And then by combining those with a differentiation term, it can catch the turning points for when things start to go up or start to go down. So with that, as opposed to say just drawing a simple tangent to the graph, you can get a whole season. You can capture a set of turns going up and down. So that's a mechanism for ARIMA. LSTM, the way it works is the running state of the cell gets influenced by the input it receives. So depending on whether or not the input is significant enough to alter the memory contained within the cell, it might be forgotten, it might be overwritten, it might be preserved. That's how it works. Can you incorporate with an expert advisor? Yeah, no, definitely. I would not recommend that anyone trade on the basis of just one model that you're doing on your own. That's not a sound basis for you to do an operation. You should, at a minimum, consider, especially for currency, you have to consider this macro stuff. It is very, very, very important. So, we sort of briefly skimmed through it, talking about the GDP and the populations, but really you have to have your handle on trade figures, weather forecast, agriculture. You should know a lot and be an expert in the UK and the US before you start thinking about this as a trade. Finding optimal P and Q is a great question. There's a series of papers about that on Google Scholar. All right, let me reference you to that one. Look up ARMA on Google Scholar. There is lots and lots of research, because it is from the 70s, so people have dug into it extensively. There is also an excellent free textbook available online, which I will try and get distributed, thanks to Stephanie's good efforts.
No worries. We'll send all the materials to you all. So do not worry about it. I will wait for Bishmar's materials as well as the recommendations that he has given. So if you wish to check out, do check them out, since it is recommended by Bishmar as well.